Today we are going to discuss about the prisoner's dilemma. Prisoner's dilemma is a very famous concept of game theory, and by the help of prisoner's dilemma we will also try to understand what is a Nash equilibrium, what is pareto efficiency, what is pareto suboptimality, and is the Nash equilibrium of the prisoner's dilemma pareto efficient or not, that will also be answered. So here are the questions that we are going to discuss in this entire video. At first we will explain the prisoner's dilemma, then we will try to find out the Nash equilibrium of the prisoner's dilemma. Here in this finding I will also discuss about the definition of Nash equilibrium, and I will also try to give the answer of another question, that is Nash equilibrium pareto efficient or not. So these are the questions that will be answered here. At first I will discuss about the prisoner's dilemma, then I will discuss about the concept of Nash equilibrium, and I will also find out the Nash equilibrium of the prisoner's dilemma, and then I will answer the last question, that is the Nash equilibrium. Is that Nash equilibrium of the prisoner's dilemma pareto efficient or not? I will also discuss about the concept of pareto efficiency, otherwise you won't be able to understand it completely. Now at first, what is prisoner's dilemma? Prisoner's dilemma is a classic scenario of game theory which illustrates individual rationality leads to a collective suboptimal outcome. We will discuss about it. I mean, you will get a fair idea about this after the completion of the video, that individual rationality leads to a collectively suboptimal outcome. In the prisoner's dilemma, we will understand after the completion of the prisoner's dilemma, you will obviously understand that the individual rationality is basically leading to a collectively suboptimal outcome, which is not a pareto efficient outcome. After the completion of the game you will understand it. For now just read it, and I will describe it again after the completion of the video. Let's break down the prisoner's dilemma and then connect it to pareto efficiency. So in prisoner's dilemma, what is the background of the prisoner's dilemma? There are two suspects which are arrested and charged with a crime. The police lack of sufficient evidence to convict the suspects unless at least one of them confesses. The police hold the suspects in separate cells and explain the consequences that will follow from the action they take. Okay, so basically there are two suspects and the police has basically arrested two of them, and the police has told that police is lacking of proofs. Police is lacking of the sufficient evidence or proof. That's why police is keeping them in different cells, and police is keeping them in different cells, and police just want that at least one of them confesses. Otherwise it will be not possible for them, for the police to give them the imprisonment. Okay, and they are kept in separate cells. Both of them prisoners are kept in separate cells, and police goes to each of the prisoners and explain the consequences of what they will do. Police give them two options: they can confess, or they can deny, or they can be silent. That means they don't know what happened. Okay, so these are the two options given to each prisoners, and police give them the consequences of that. What will happen if they decided to confess? What will happen if they decide to be silent? Okay, so the police also gives them the option to do that, and police also tells them the consequences or results that will happen if they choose to confess, or if they choose to remain silent. Okay, now who are our players? Basically we have two players in the prisoner's dilemma. The two players are basically the two prisoners of the game. Okay, so the two prisoners are our players of the game, and the two prisoners has to decide whether to be mum or whether to think. Here mum means to accept the crime, and think mean to remain silent. Sorry, I have wrote it wrong here. It is written in a wrong form. Sorry. Here mum means, let me clear it. It is written wrong. Here mum means to be silent, and think means accepting the crime, accepting and confessing that the crime has been committed. Okay, so this was our background for the prisoner's dilemma game. Now, payoffs. What are the payoffs? Payoffs are basically the amount of sentences, that is amount of imprisonment that each of them will get for their decisions. The imprisonment that the prisoners will get for each of their decisions taken by them will be their payoff. Now, if they both decided to mum, that is remain silent, then they receive light sentence. That is 1 year of imprisonment for both of them. If both decide to think, that is confess, they get a very heavy sentence with 6 years of imprisonment for both of them. If one confesses and another prisoner remains silent, the prisoner who is remaining silent will get a very severe sentence, and which is known as sucker's payoff. And the prisoner who is confessing will be free, completely free. That means he will not get any imprisonment. That is called temptation payoff. Now, if we want to represent it by a bimatrix, what is a bimatrix? Bimatrix is basically a matrix in which we have two players of a game. There are two numbers in each cell, and representation of prisoner's dilemma. As you can see, there are two numbers in each cell, and we have two players, prisoner 1 and prisoner 2 in the game. So this is basically a bimatrix. Okay, so in this bimatrix we may see that there are two options to each prisoner. One is to remain silent and another one is to be confess. Similarly, for prisoner 1 there are two options, to remain silent or to confess. Now, if player 1, as you can see, if prisoner 1 remains silent, that is to be mum, and prisoner 2 also remains silent, that is to be mum, they both get 1 year of imprisonment. If prisoner 1 remains silent, that is to be mum, and prisoner 2 decides to be think, that means to confess, then this is the payoff. That means 9 years of imprisonment for prisoner 1 who has been confessing, who was silent, who was silent, and 0 year of imprisonment for the prisoner who was confessing. So as you can see from here, if prisoner 1 is remaining silent and prisoner 2 is confessing, then this is our payoff, minus 90. That means 9 years of imprisonment for prisoner 1 and 0 year of imprisonment for prisoner 2. That means prisoner 2 is being set free. So basically, the first payoff is representing the payoff of the first number is representing the payoff of prisoner 1, and the second number is representing the payoff of prisoner 2. That is also a very important point that has to be remembered. Similarly, if prisoner 2 remains silent, that is to be mum, and prisoner 1 decides to be mum, then we have this payoff. We have already discussed about it. If prisoner 1 remains silent, if prisoner 1 thinks, suppose this is our payoff. If prisoner 1 thinks, that is to confess, and prisoner 2 is remaining silent, then this is our payoff. Prisoner 1 is getting 0 years of imprisonment and prisoner 2 is getting 9 years of imprisonment. Okay, so prisoner 1 is basically free here. Prisoner 1 is confessing and prisoner 2 is remaining silent. So basically prisoner 2 is remaining silent and getting 9 years of imprisonment, and prisoner 1 is confessing and getting 0 years of imprisonment. Similarly, if both of them confesses, that means if prisoner 1 confesses and prisoner 2 also confesses, that is think, both are getting 6 years of imprisonment. So I hope this matrix is clear. Now we will lead to the Nash equilibrium. If prisoner 1 remains silent and prisoner 2 also remains silent, then they both receive 1 year of imprisonment. That is what I have told in the earlier section also. If both are remaining silent, then both are getting 1 year of imprisonment. If prisoner 1 decides to remain silent and prisoner 2 decides to confess, prisoner 1 remaining silent, that is prisoner 1 remaining silent, that means prisoner 1 is taking the strategy of mum, and prisoner 2 is confessing. He is not remaining silent, he is confessing, that is he is thinking. So this is our payoff, 9 years of imprisonment for prisoner 1 and prisoner 2 is having 0 year of imprisonment. Prisoner 1 will receive 9 years of imprisonment and prisoner 2 will be set free. So sucker's payoff for prisoner 1. Prisoner 1 is surviving, prisoner 1 is suffering the payoff of Asakar, which is 9 years of imprisonment, and prisoner 2 is getting the temptation payoff, which is basically being set free or not getting any imprisonment. Now, if prisoner 2 decides to remain silent and prisoner 1 decides to confess, prisoner 2 decides to remain silent and prisoner 1 decides to confess. So this is our payoff 0, minus 9. That is 0 years of imprisonment for prisoner 1, 9 years of imprisonment for prisoner 2. Prisoner 1 will be set free and prisoner 2 will receive 9 years of imprisonment. So here in this case, Sakar's payoff is being received by the prisoner 2 and temptation payoff is being received by the prisoner 1. 9 years of imprisonment, which is Sakar's payoff, is being received by the prisoner 2, and temptation payoff, which is basically being set free, is being received by the prisoner 1. And the last case, if prisoner 1 presented to both, if prisoner 1 and prisoner 2, here prisoner 2 is supposed to be added. If prisoner 1 and prisoner 2 both decides to confess, then they will be receiving 6 years of imprisonment. As you can see, if both decides to confess, then this is our payoff. So they will both be receiving 6 years of imprisonment. Now, what is a Nash equilibrium? Before telling the Nash equilibrium of this prisoner's dilemma game, I have to clear the definition of Nash equilibrium or the idea of Nash equilibrium. Well, in the game theory, Nash equilibrium is a situation in which a player will continue with their chosen strategy, having no incentive to deviate from it after taking into consideration the opponent's strategies. It was proposed by John Nash. So Nash equilibrium is a set of strategy which will be chosen by each player and they will not deviate from it. As you can see from this game, both are actually, as you can see from here, if prisoner 1 was remaining silent, prisoner 2 also was remaining silent, then they both receive 1 year of imprisonment. Okay, I will tell this story, I will come to this story. Before that, let me form 4 different cases. After that, you will understand the definition of Nash equilibrium much more accurately. But I may tell you something about before telling these 4 cases. Nash equilibrium is a condition in which no player is ready to deviate from it. That means Nash equilibrium, if it is present in the game, then both of the 2 players will accept that strategies and they will be in that strategy. So Nash equilibrium is a strategy in which both of the players are satisfied with that strategy and they will not shift from that strategy. They will not shift means they will not choose any other strategy. If Nash equilibrium is present in that game, then they will not choose any other strategy and they will choose Nash equilibrium only, and they will not deviate from it because there is no incentive in it. If they deviate from the Nash equilibrium, they will not find a better outcome. Okay, so that's why they will not deviate from it. So basically, let me check the 4 cases at first. Case 1 is prisoner 1 decides to be silent. Now, if prisoner 1 decides to be silent, watch this very much well. Prisoner 1 is deciding to be silent, that is to be mum. So these are the 2 matrix, these are the 2 strategies available, right? For prisoner 2, these are the 2 strategies available. Prisoner 2 can be mum or prisoner 2 can be fink, that is to remain silent or to confess. So now, if prisoner 2, the second number is denoting the prisoner's 2's payoff and the first number is denoting the prisoner 1's payoff. So if prisoner 2 is selecting mum, then the prisoner 2 is getting 1 year of imprisonment. And if prisoner 2 is getting or selecting the fink option, then prisoner 2 is getting 0 years of imprisonment. So prisoner 2 will be set free. So prisoner 2 will obviously select the option of fink, that is to confess. Okay, so when prisoner 1 was remaining silent, prisoner 2 is choosing to confess or to fink. So as you can see here, in the first case, if prisoner 1 remains silent, prisoner 2 also remains silent. Sorry, this was not the case. This is the case. If prisoner 1 decides to be silent, then prisoner 2 will decide to be confess. because 0 is less than -1, being free is less than 1 year of imprisonment. As I have told you also here, if prisoner 2 decides to be mom, prisoner 2 is getting 1 year of imprisonment. But if prisoner 2 is deciding to confess, then he is getting 0 year of imprisonment. So being set free is less than 1 year of imprisonment. So obviously prisoner 2 will decide to confess. So if prisoner 1 decides to be silent, then prisoner 2 will decide to confess. So 0 is less than -1, being free is less than 1 year of imprisonment. Similarly for case 2, if prisoner 1 decides to confess, what will happen? Now, if prisoner 1 decides to confess, this was the case, right? Prisoner 1 was deciding to confess. Now, these are the two matrices available. These are the two strategies that are available. Now, two options are there for prisoner 2. He may select mom, he may select fink. If he selects mom, he will get 9 years of imprisonment. And if he selects fink, that is to confess, he will get 6 years of imprisonment. Okay, now understand it properly. Obviously, the prisoner 2 will choose 6 years of imprisonment rather than choosing 9 years of imprisonment. So prisoner 2 will choose to confess because he is choosing the 6 years of imprisonment rather than choosing 9 years of imprisonment. He will choose this rather than choosing this. Okay, so prisoner 2 is selecting to confess or fink. So as you can see here, it is written here, if prisoner 1 decides to confess, then prisoner 2 will also decide to confess. That is -6 is less than -9. 6 years of imprisonment is less than 9 years of imprisonment. What is the case 3? If prisoner 2 decides to be silent. So if prisoner 2 decides to be silent, this is our prisoner 2. If he decides to silent, then prisoner 1 has two options. Prisoner 1 may select, these are the two strategies that will be in consideration here. Prisoner 1 has two options, whether to mom or to fink. Now if prisoner 1 has two options, if prisoner 2 decides to be silent, that is this, then these are the two strategies that are available. Now prisoner 1 may select mom or may select fink. If prisoner 1 selects mom, then he will get 1 year of imprisonment, and if prisoner 1 selects fink, he will get 0 years of imprisonment. So obviously prisoner 1 will select to fink, that is to confess. So if prisoner 2 decides to be silent, prisoner 1 will confess because 0 is less than 1, being free is less than 1 year of imprisonment. Last case, if the prisoner 2 decides to confess. If the prisoner 2 decides to confess. So the prisoner 2 has decided to confess, right? Then these are the two strategies which are into consideration. Prisoner 1 has two options, mom or fink. What will he do? If he decides to mom, then -9 will be his payoff. If he decides to fink, -6 will be his payoff. -6 is less than -9. 6 years of imprisonment is less than 9 years of imprisonment, right? So he will obviously choose to fink, that is to confess. So if prisoner 2 is confessing, then prisoner 1 will also select to confess or fink. As you can see from here, if prisoner 2 decides to confess, prisoner 1 will also confess because 6 years of imprisonment is less than 9 years of imprisonment. Now what is happening here? Which case is Nash equilibrium? Case 1, case 2, case 3 or case 4? Basically, as you can see in case 2, when prisoner 1 was deciding to confess, prisoner 2 was also deciding to confess. And in case 4, when prisoner 2 was deciding to confess, prisoner 1 will also decide to confess. So this case 2 and case 4 is showing that when one of the prisoner is confessing, the other is also selecting to confess. When one of the prisoner is confessing, then other prisoner is also selecting to confess or deciding to confess, that is fink. That means this strategy is -6, that means 6 years of imprisonment for both is the Nash equilibrium. Okay, so case 2 and case 4 are the Nash equilibrium. It is case 1 and case 2. So both player will continue their chosen strategy, that is to confess, and they both don't have any incentive to deviate from it after making into consideration of other opponent strategies. after considering other opponents' strategies, they don't have any incentive or they don't have any wish to deviate from this Nash equilibrium strategy. So the Nash equilibrium is confess, that is denoted in case 4 and also in case 2. Now the definition will be completely understandable. As you can see the definition now. This is the definition. So they are choosing a strategy and they have no any incentive. They don't have any incentive to deviate from the strategy. Right? As you can see from the game, when player 1 was choosing confess, player 2 is also choosing confess. So they both are happy with that. Player 1 choosing confess, player 2 is also choosing confess. Similarly, when player 2 is also choosing to confess, player 1 is also choosing to confess. So they both are really satisfied with this strategy and they don't have any incentive or any wish to deviate from this strategy. So this confess is our Nash equilibrium. Okay. Now the concept of pareto efficient outcome or pareto optimum outcome or pareto optimum state. This concept is supposed to be cleared because of the last question that was asked, that whether the Nash equilibrium, which is confess or think, whether it is Pareto's efficient or not. We have to understand that. So for understanding that, at first I have to clear the definition or idea of Pareto efficiency. What is Pareto efficient outcome, or what is Pareto optimum outcome, or what is Pareto optimum state? A Pareto efficient outcome is an action that harms no one and helps at least one person. So it makes at least one person better and it doesn't harm anyone. So if there is any outcome possible which makes one person better and at least one person better, if it makes 2% better, then that is very good. But at least one person, making at least 1% better, and without harming the other person or any other person, then that will be Pareto efficient outcome. A situation is Pareto efficient if the only way to make 1% better off is to make another person worse off. Okay. So this definition, if you don't like, don't read it. It is very much beautiful. This definition, the first definition, is very much easy to understand. So a Pareto efficient allocation or a Pareto efficient outcome is an outcome where it is not possible, or a Pareto efficient outcome is an action that harms no one and helps at least one person. Okay, and if it helps 2% or makes 2% better off, then that is very good. Okay, so in Pareto efficient allocation, if we are in Pareto efficient allocation, then it is not possible to make anyone else better or without making anyone else worse off, because we are in already Pareto efficient allocation, right? That means it is the best allocation or best outcome possible for all of them. So in this allocation, if we are in this allocation, that it is not possible to make one person better off without making another person worse off, right? So if we are in the Pareto efficient allocation, or if we are in the Pareto efficient outcome, then both of them, or if there are two players only, or if there are two individuals only, then both of them are having the best results for them or best allocation for them. Now if I want to make someone better off, then I have to make the other person worse off, otherwise it won't be possible. So the Pareto efficient allocation is when the 1% is better, when it is impossible to make one person better off without making another person worse off. So a situation is Pareto efficient if the only way to make one person better off. So if the only way to make one person better off is to make another person worse off, then that situation will be Pareto efficient, because there is no other way to make that person. Suppose there are two persons, one and person A and person B, and they are in Pareto efficient allocation. So if I want to make A better off, I have to worse the condition of B. That means I have to basically take something from B and give that to A. So this type of, if we are in this type of condition, then the condition will be obviously the outcome is obviously Pareto efficient. That's why it is not possible to make anyone better off without making someone worse off. Okay, or the only way to make someone better off is to make another person, that is this person, worse off. Now what is Pareto inefficient outcome? Pareto inefficient or suboptimal outcome is basically if there is some state of affairs y such that no one strictly prefers x to y and at least one person strictly prefers y to x. That means suppose let me give the example with this game. As you can see with this game, if both of them selects to mum, that is to remain silent, then they both of them are getting 1 year of imprisonment. In Nash Equilibrium, both of them are getting 6 years of imprisonment. Okay, but in this case, if both of them are selecting 1 year of imprisonment, that is can be obtained by remaining silent, then in this case they can be better off, right? Now what do we call this -6? This situation can be improved if I consider this is x and this is y. This is let me go by the definition. If only there is some affairs y such that yes, y. This is x and this is y. If the prisoners come out and the prisoners watch the entire matrix, both of them without any doubt will select y over x, because y is giving them low sentences. Each of them is getting low sentences by selecting y rather than selecting x. So this x is nothing but Pareto inefficient outcome or Pareto suboptimal outcome. If we go by the definition, we will understand x is Pareto inefficient. X is nothing but -6. Y is nothing but -1. So x is Pareto efficient because there is a affair or outcome y which is available and y is preferred over x. Y is preferred over x. Anyone can prefer y over x because y is giving them lesser imprisonment. Okay, so y such that no one strictly prefers x to y. Nobody will prefer x to y, right? Because x is 6 years of imprisonment, y is 1 year of imprisonment. So nobody will basically prefer x over y. So basically at least one, and obviously not just one, both of the prisoners will here select y over x, right? Because y is giving them less year of imprisonment, that is only 1 year of imprisonment. So x is nothing but Pareto inefficient or Pareto suboptimal outcome because there are some outcome y exist which is giving them lesser imprisonment. So x is Pareto inefficient. It is not Pareto efficient. So which one is Pareto efficient? This y is Pareto efficient. If they are selecting this mum, if they are selecting this mum, then they are getting 1 year of imprisonment each. In this situation you can't make them better off. If you have to make any one of them better off, you have to make another one worse off. If I want to make prisoner 2 better off, right, then what is the option of making prisoner 2 better off? The only option to make prisoner 2 better off is selecting these strategies. In this strategy -90, prisoner 1 is remaining silent or mum and prisoner 2 is confessing, and prisoner 1 is getting -9, prisoner 2 is getting 0. So in this situation we can make prisoner 2 better off, but prisoner 1 is getting worse off. At first he was getting -1 year of imprisonment, now he is getting -9 years of imprisonment. So in this situation you can't make anyone better off without making another one worse off. So this is Pareto efficient. This -1, this outcome is Pareto efficient. Because if you want to make prisoner 2 better off, prisoner 1 will be converted into a worse off situation. If you want to make prisoner 1 better off, that is 0 year of imprisonment, prisoner 2 will be in a worse off situation. And in this strategy they are both getting worse off. Okay, so this is our Pareto efficient outcome and this is our Pareto inefficient outcome. And if you remember, which one was Nash equilibrium? -6 was Nash equilibrium. So our Nash equilibrium is nothing but a Pareto inefficient outcome in prisoner's dilemma. Okay, because our Pareto efficient outcome in prisoner's dilemma is mum, is the strategy mum or 1 year of imprisonment for both of them. I hope this is clear. Now if I just read this loud, what is the case of Nash equilibrium? This is done. 11th slide is done. 12th thus this is. The Nash equilibrium in the prisoner's dilemma is that both the prisoners are 1 minus 1. Both the prisoners are minus 1 choosing to confess. This should be in bracket. This 1 should not be here and this minus 1 should be in bracket. Okay. So in the Nash equilibrium in the prisoner's dilemma is both the prisoners are choosing, you can cut it, both the prisoners choosing to confess and each getting, this is not required, 1 minus 1, this is not required, choosing to confess and each getting 6 years of imprisonment. But there is another outcome, that is if they have chosen to remain silent, then both of them will be having imprisonment of 1 year only. So that means that there is another outcome possible which is better than the outcome of Nash equilibrium. So we can say Nash equilibrium in prisoner's dilemma is pareto inefficient or pareto suboptimal, and Nash equilibrium is not pareto efficient. Pareto efficient outcome is when both of them are remaining silent and getting 1 year of imprisonment. That was I have described there also. Thank you for watching the video.